Hello, eighth grade. This is Mr. Lipscomb. I'm going to help you with a couple problems on tonight's homework. I just want to make sure you know how to do it. The even problems on lesson 12, 2 through 18. Why can't I grab this string? Just keeps getting further. I don't know. Whatever. Okay, let's see if we can do this homework. Enough goofing around. Okay, so here are the two problems that we're going to do. This is number 16. So number 16 and number 18 on the homework. And the job is to write your answer in set notation, and graph it, and then check your solution. So let's start off with number 16 here. Okay, let's do this. 16. Now, I want you to know that all of the problems on 2 through 18, it turns out, are problems that you were expected to know how to do coming into this class. These are problems that were part of the initial assessment in ALEKS that you should know how to solve for. So while they might look a little bit different, all of the properties that we're going to use to solve these were ones that were you're expected to know coming into this class. So but of course, we need to refresh our memories on maybe a few of these things, so on how to solve these problems. So let's go ahead and do that. So first things first, let's just copy the problem. Now, I want to remind you of the four things that we learned at the beginning of the year. That is, when you're solving a problem, you copy the problem. 2 is you solve it. These are things that you wrote down and you've supposed to have been doing all year. Most of you have been very good at it. Then you box your answer. You commit to your answer. And then 4, you check your work if possible. And on these problems, checking your work is possible. So I'm going to expect you to do all 4 of these steps. In fact, you are called for in the instructions to check your solution. So without further ado, let's move forward. We're going to work in dark blue ink. So Mr. Lipscomb, I hate fractions. So what I'm going to use on both sides of this equation is I'm going to look at a number that I can multiply everything through by and get rid of all the fractions. And I see that that number is 9. Hopefully you can see why multiplying everything by 9 will get rid of all my fractions. So I'm going to use the multiplicative property of equality and multiply both sides by 9. And now what do you see we get? What do you see that we have? We have, after we multiply both sides by 9, if we have an equality and we can multiply both sides by a number, we can add the same thing to both sides, but here we're multiplying, we end up with what looks like a distribution problem. So let's do our distribution and draw our arrows. We have 2 problems here, or 2 multiplications. So we get 18 plus x. If that doesn't make sense, why 9 times x over 9 equals x, then you need to come ask me about that. But this is something that I expect you to know. And now we're going to do distribution on this side. And remember, we can distribute in either direction, left to right, right to left. 9 times x, 1/3 of x, or x over 3, is 3 x's. Let's make a better 3, Mr. Lipscomb. 3x, and negative 3 times 9 is minus 27. Now, my next goal, so I've distributed. I've used my multiplicative property of equality. I've then distributed. Now I have this problem. Now what I want to do is I'm going to get all my x's on the right. That's going to be nice because if I subtract x from both sides, I can get rid of my x on the left. And then I'm going to do the same thing. I'm going to get rid of my 27 on the right. And I can do that, right? So I can do this because negative 27 minus x is the same thing as negative x plus 27. We're just going to add down. We're going to add down this equality. I'll change color just for fun. And we're going to get 2x when we add these things. These cancel. These x's cancel. And I get 45 equals 2x. So I get And now I'm going to use my division property of equality, and I get x equals 45 over 2. You could also use our reflexive property, and we could say x equals 45 over 2. We can write it in the other direction. We can box that. Another approach would be to say, well, I'm going to do my division, and I'm going to say x equals 22.5. Either one of those answers is fine. So we have copied the problem. We have solved the problem. We have committed to an answer. Now we simply need to check our work. Oh my goodness, this is ugly already. Let's see. So let's go 2 plus 45 halves over 9 equals 45 halves over 3 minus 3. All right, so 45 halves over 9, I'm going to expect that you can do that math, and it's going to come out to be 45 over 18. 45 halves divided by 9 is the same thing as 45 halves times, that's 45 halves times 1/9, and there's where I get my 45 over 18. 45 halves divided by 3, similarly, is 45 over 6 minus 3. Okay, now if I multiply, now I'm going to continue to work this through and see if I can make sense of this. Let's simplify this guy here, and we can get 45 halves. We can divide the top and bottom by 9, and we get 2 plus 5 halves. And here we can divide both of them by 3, and we can get 15 halves minus 3. So let's turn this into 4 halves. 4 halves plus 5 halves. Does that equal 15 halves minus 6 halves? And the answer is yes, because this is going to be 9 halves, and that's going to equal 9 halves. And there we've checked our work. So we've done everything that's been required by Mr. Lipska, but one other thing we have not done is we haven't written our answer in set notation. So to simply say write this in set notation, we're gonna have to do this. That's set notation. And to graph an equality in set notation, we're gonna here. Let's just pop. So we know the answer is 45 halves. Let's just pop over to the next page, and I'm just gonna make a quick and dirty number line. And I know my answer is 45 halves, or 22.5. So I'm going to make a number line that goes 21, 22, 23, 24, and I'm going to make a big dot here, and I'm going to say, 45 halves. I'm just doing this to make it obvious. If you didn't even put the 45 halves on here, but you put that dot right in the middle, we'd be good to go. Now that's the harder one. Let's go back and look at this other problem. X plus 4 over 3, and x plus 2 over 5. Wait a minute. My memory's no good. Okay, so x plus 4 over 3 and x plus 2 over 5, x plus 4 over 3 and x plus 2 over 5. This is the problem we're solving. So we've copied our problem. Now, this is a cross multiplication problem. Right? So we're going to cross multiply to solve. So we say 5 times x plus 4 equals 3 times x plus 2. Now let's do this with our arrows to really help us out here, not screw this up. 5x plus 20 equals 3x plus 6. I'm going to get my x's on the left side here, so let's subtract 3x, and we get 2x plus 20 equals 6, minus 20, minus 20, 2x equals negative 14, x equals negative 7. Commit to our answer, and remember that we need to put this in set notation. So let's just do that right now. Let's commit to that answer. Now we need to check our answer, and we need to see if negative 7 works in our original equation. So we're going to plug a negative 7 in for x and here for x. Let's just check. This is our check step. Negative 7 plus 4 over 3, does that equal negative 7 plus 2 over 5? So that will be negative 3. Does negative 3 over 3, does that equal negative 5 over 5? Well, negative 1 does equal negative 1, so our check step is complete. So we've checked negative 1 is negative 1, there's negative 7. And we're going to now graph our solution. And to graph our solution, we just put a negative 7, a negative 8, a negative 6 on our number line. And we're going to put a big circle on negative 7. And there's our answer. Set notation, check step, all wrapped up in a nice bow, a nice bow, maybe a nice bow tie. And that's that. So I don't know. I still can't get this eyepiece off me. Oh, there. Good. Okay. I'll see you in class tomorrow.